Hello everyone. We will be discussing about one of the very important problems asked in many of the interviews, palindrome number. So here, if you can see in the lead code problem, they have mentioned 121 reads as 121 from left to right and from right to left. So if we have 121, we reverse it 1, 2, 1. It is exactly the same. So here, this is called palindrome number. Whereas if we take some other example, let's say 567, and we try to reverse it 7, 6, and 5, then it won't be a palindrome number because it is not same. So that is the logic behind palindrome number. But there are some edge cases. First edge case is single digit. So if a number is just a number, let's say 1, if you reverse it, it is still the same. So single numbers are always palindrome numbers. Negative number, so let's say -2, if you reverse it, it will become 2 minus, which is not a palindrome number. So negative numbers are never palindrome numbers. Numbers ending with 0, 120, let's say. If you reverse it, it will become 0, 2, 1, and it will be like 21, which is not a palindrome number of 120. So numbers ending with 0 will not be palindrome numbers. These are the edge cases which we have to handle during writing the code. Let's discuss about the pseudocode. So the logic is first take the, like, let's say we have a number, um, 121, which is a palindrome number. But to write the code, the logic will be take the last digit of the number. So that will be done by 121 modulus 10. It will give you the last digit, which is 1, which is a remainder. Second step is add it to a new number. So let's say I have defined a new number, new number equals to 0. So we have to add this number to new number by multiplying it by 10. So new number into 10 plus this number. So this, let's say it is d plus d. So it will give you 0 into 10 plus 1, which is 1. Then third case, remove the last digit from the original number. So let's say my original number is n. So I have to remove the last digit. So n by 10 will give me last digits, and let's store it in n. So it will be 121 by 10, which will be 12. Now repeat the remaining, repeat for the remaining digits. So this whole we can put into a while loop. So while n is greater than 0, this should follow. Now first step is complete. So let me try it for the second time. So now our number is 12. So number is 12. First step is take the last digit of the number. So 12 modulus 10 will give me 2. Second step is add it to the new number. So now we have, this is the new number 1. So 1 into 10 plus the number which is 2. So we have got 12. Then third, remove the last digits from the number. So now the number is 12. So 12 by 10 will give me 1. Now our number is 1. We'll again do it because it's greater than 0. So first step is take the last digit of the number. So 1 modulus 10 will give you 1. Second step is add it to the new number being built. So 12 into 10 plus 1 will give me 121. Third is remove the last digit. Remove the last digit from the original number. So the original number here was 1. If we divide by 10, we'll get 0. Now here we have to stop because while n is greater than 0 condition is false. So this, and this is the number which we get. Now we have to compare this number got here 121 with the original number which we took 121, which is equal. Hence, it is a palindrome number. So this is the logic for the. It's better if you try it once on your own. The code will be present in the description of this video, but let's try it with a simpler approach in Python. So I'll share my coding environment right now. So here we go. So let's say a number is 121. Python gives us a short form for checking which numbers are palindrome. not numbers, it gives for string, but we can use that for numbers as well. So let's say if I talk about a string, my string is ABA, which is a palindrome string, and I write uh, palindrome of S as S, such that now what it will do, it will reverse the elements in S. And now if I print, it gives me ABA. The palindrome of S is exactly equal to this. So if I write S equals pal of S, so it should give me true. So this is one of the form we can use for strings. But right now when we are dealing with integers, what we can do is we won't be able to do use this function directly, slicing. Otherwise, it will give you an error. So I will just show what error we will get. Let's say a palindrome of A equals to A, and we are trying to reverse it. It will give you some error, which is int object is not subscriptable. So simple, we can convert this number first to string and then we can try the same thing. So let's convert a str equals to string of a. Now our a is converted into string, and now we can apply that palindrome of a str equals to a str minus 1. Now if you check, it's a. Now it works 121. Now, on top of it, we can just check, is it equal to ASTR? True. So we can use that. So in case of numbers, we can just put this string operation before that number and use the direct inbuilt method which is provided by Python. And this is one of the ways we can directly use one line of code to check for palindrome numbers. If you want to go for the ones which I showed in the pseudocode, the entire code is present in the description of this video. Thank you.